Hi. Firstly, I'd like to introduce myself. I'm Mohamed Manaouch, a PhD student at Ibn Tufayl University. My topic today will be about assessment the effect of land use land cover changes on soil loss and sediment yield using WATM-SEDIM model in the Ziz upper watershed in southeastern Morocco. Before starting, soil erosion is the displacement of the upper layer of soil. It is one form of soil degradation caused by the dynamic activity of erosive agents, that is, water, ice, snow, air, plants, animals, and humans. In Morocco, soil erosion affects 75% of the national territory. The cumulative annual losses are estimated at 100 million tons of sediment, 50 million cubic meters of water lost each year by siltation in large dams. For the wettest dams, it suffers from siltation of 1.47 million cubic meters per year. In this study, we aimed to assess soil erosion and sediment transport in these upper watersheds under current, past, and future conditions by using WATM-SEDIM model and GIS. Our study area, this upper watershed, is located upstream of the Hassan Dakhil Dam on Ouadziz in southeastern Morocco. The following table presents the main characteristic of this upper watershed. What MCD model used in this study is a spatially distributed soil erosion and sediment delivery model created by a group of geomorphologists in Catholic University of Leuven in Belgium. This model combined the WATM, that is water and tillage erosion model, and SEDIM, that is sediment delivery model. We used this model because the modeling of land use and land cover changes is essential for natural resource scientists, decision makers, and planners in developing comprehensive medium and long-term plans for tackling environmental and other related sustainable development issues. This model consists of three modules. The first, for calculating water erosion, the second for estimating sediment transport, and the last for tillage erosion. When we use the WATM-SEDIM, we need to calibrate its parameters KTC and KTL. For water erosion, it is calculated based on the revised universal soil loss equation following the first formula. A represents the average amount of soil loss caused by gully erosion and equal a product of five factors. For sediment transport, it is calculated by using TC equation. TC is the transport capacity and it depends on KTC and universal soil loss equation factors. For tillage erosion, it is calculated using the third formula with Q, the net downslope flux due to tillage translocation of soils. For WATM-SEDIM model process, it can be explained in the following steps. Firstly, we prepare the dam of the study area for extracting LS map, and we prepare all the maps for different factors. WATMCDM calculates the potential erosion. This potential erosion will be compared with TC, that is transport capacity for routing of sediment. Then we have two possibilities. If this amount of potential erosion is less than Tc, we will have erosion. In contrast, if this amount more than Tc, we will have deposition of sediment. So in the following landscape, we have red pixels represents areas with erosion, and the green pixels represent the seats of deposition. In these figures, we explain the approach used by WATMCDM model. This model requires factors map and them for extracting LS factor. Then after calibration of the model, we have as a result net water erosion maps. So we need in this application of WATMCDM model, we need to use GIS software and remote sensing software. So in these maps, we prepared all the GIS layers that required WATMCDM for its application. Here, WATMCDM requires that the GIS layer must cover the exact same area and all the maps must have the same resolution. For example, a rainfall erosivity map and soil erodibility map must have the same resolution. Among different maps required by WATMCDM, we have parcel map or land use land cover map. For the disease upper watershed, the current parcel map is largely dominated by poorly vegetated areas, followed by degraded forest and agricultural land. We talked before about WATMCDM calibration. This operation consists in changing KTC and KTL until we obtain the same result of simulation of models and the measured data. So for estimating the model efficiency, we used Nash and Sutcliffe equation. And for estimating the model's accuracy, we used the relative root mean square error. This figure illustrates the calibration procedure. For disease upper watershed, we have two periods. The first is used for calibrating the model, the second for validating the results. And we found that KTC equal 477 meters and KTL is about 0 meters. To assess the effect of land use land cover changes on soil erosion and sediment yield in this upper watershed, we reproduced three situations. The first in 1936, the second in 1957, and we compared the result with the current situation. These figures illustrate that this upper watershed in 1936 was largely occupied by degraded forest, and for current situation it is largely dominated by poorly vegetated area. So this result explain a decrease of degraded forest, whereas poorly vegetated area have increased considerably. What MCDM gives two types of results, tables and maps. For the tables, it gives total sediment production and total sediment deposition and total river export, then sediment yield and the specific sediment yield. For different situations of land use land cover in this upper watershed, in 1936 the specific sediment yield was weak and was about 0.37 ton per hectare per year, and in 1957 it was 3.57 ton per hectare per year. For the current situation, it is about 4.58 ton per hectare per year, and for the projection, it will be 5.6 ton per hectare per year. So the study revealed that the sediment yield increased 80 times, and the table above and figure illustrate the trend of soil erosion and together with the spatial distribution of erosion severity maps. For the projection, we suppose that there was no degraded forest and the disease upper watershed will be dominated by poorly vegetated areas. As a conclusion, in this work we have shown that the calibrated WATM-CDM model can be used to assess soil erosion and sediment yields under current, past and future land use land cover situations. For current situation, the specific sediment yield is 4.58 ton per hectare per year, while for 1936, 1957 and current situation were 0.37 and 3.57 and 4.58 ton per hectare per year respectively. The results also showed that the transition of degraded forest areas from steep slope of the watershed to poorly vegetated areas caused high rate of soil loss and sediment yield, such as the results revealed that sediment yield at the catchment outlet of this upper watershed follows the Lulk changes. The spatial distribution of soil severity classes showed an increasing trend from moderate to high and severe classes, while areas under slight soil severities classes decreased slowly. Thank you very much for listening.